Good day! I'm Dr. T, and this is a Q&A video. Questions are taken from class discussion boards and YouTube comments as of April 26th, about 8:30 p.m. A little bit after that, but pretty close to it. Okay, so all the questions are coming from the CAM 1152 discussion boards, actually kind of two posts. So I'm just going to kind of go over a few of these, and I'll put the list up with timestamps like usual. Okay. What's the first step in polysaccharide metabolism? Make them monosaccharides. So step one, cleave those critters. Glycogen or starch has got to get to glucose before you can do anything to it. Carbohydrate metabolism is broken into two major parts. Those are going to be glycolysis, which happens in the cytoplasm, and the citric acid cycle, which happens in the mitochondria. You could argue TCA, that is citric acid cycle. You could argue electron transport chain, which is also in the mitochondria. That's going to be the inner mitochondrial membrane and the inner membrane space. That's kind of a third part of it. Depends on how you want to think about that. But the citric acid cycle, aka TCA cycle, that happens inside the mitochondrial matrix, which is the inner part of the mitochondria. What cofactors are used in glycolysis? The key ones are going to be NAD/NADH and then ATP. Trying to think if there's any. There's probably a couple of. Those are going to give you two coenzymes. I'm trying to think if there's any prosthetic groups or anything funky like that. Top of my head, I don't remember that there being it, but those are the main ones: NAD/NADH, and then ATP. Okay, where does ethanol enter metabolism? That's going to, your liver is going to take ethanol. It's going to go ethanol, formic acid, or sorry, not formic acid, that's bad if it does that. Ethanol, acetic acid, acetyl-CoA. Now, acetyl-CoA is the beginning part of the citric acid cycle. So, boom, it's going to go in there. What are cytochrome P450 enzymes? So I've got actually a video on this one that I'll link in the description. Short answer is these are enzymes, one of several, this is a large class of enzymes, that handle xenobiotics. These are just weird chemicals. Your body's like, I don't know what this is. I'm going to make it go away. And their job is to oxidize them, put alcohol groups on them to help your kidneys make them go away. You know, number one down the toilet. Yeah, so there's more on that on the video. They're one of a couple of ways, really important for pharmaceutical work. What is pharmacogenetics or genomics? This is your genome linked with your pharmacology. So how does mutation affect how you respond to drugs? So do you have a mutation that affects how one drug will affect you? That's why some people are more sensitive to some drugs than others. Actually, the P450 video talks about this one as well. What are two chemicals created by fermentation? Well, it depends on what you are. So if you are a human, it's lactic acid. If you are a bacteria or a fungus, you could do lactic acid, or you could do ethanol fermentation, which is ethanol and then a CO2. So it depends on what you are, so those would be your choices, lactic acid or ethanol plus CO2. Under what conditions do organisms ferment? When it's anaerobic, when they don't have enough air. So if they got oxygen, they typically will go through glycolysis, citric acid cycle, electron transport chain. But remember, if you can't do electron transport chain, you cannot recycle your NADH back to NAD. And thus you run out of cofactors in your glycolysis and you're up a creek. So fermentation allows that recycling step to take place. Most organisms will choose one of two chemicals during fermentating. What are the, I just answered that one. So yeah, once again, lactic acid or CO2. I'm assuming these are two different posters. Okay, which chemical do we, humans, we will make the lactic acid. So yeast will make ethanol, we make lactic acid, and that allows us to do Cori cycle. If we made ethanol, we could not do Cori cycle with that. Instead, we do lactic acid, which does a lot of Cori cycle. What makes the cycle a cycle? it's a pathway where the starting products and the ending products are the same thing. So if you look at citric acid cycle, you're going to start out with, you're going to make citric acid and you're going to use oxaloacetate to make that. Well, that's what you make in the citric acid cycle. Cori cycle, you've got glucose going to lactic acid and lactic acid going back to glucose. It's a circle. With respect to hemoglobin, what role do BPG, acid base, oxygen, carbon monoxide? That's a long discussion. I've got a video specifically on this. I will let you look that one. It'll be linked in there. What's CRISPR-Cas9? So SciShow did an excellent video on this a little while back. I've got that linked in the description as well. Long story short, CRISPR is a guide RNA. It's a small RNA. And then Cas9 is an enzyme that uses CRISPR to figure out where it needs to cut DNA. And the beauty is, because you've got a guide RNA, it's very easy to write a sequence and say cut here, and that way we can just dial a cut. And that's step one in a lot of genetic engineering, which this is gold for genetic engineering. Absolute major, major breakthrough. Okay, that's the list of questions for today. I'll be keeping an eye on discussion boards and or YouTube comments. Otherwise, have a wonderful day, and see you in next videos.